For my problem, I have this one that goes, two children fight over a 200-gram stuffed bear. The 25-kilogram boy pulls to the right with a 15-Newton force, and the 20-kilogram girl pulls to the left with a 17-Newton force. Ignore all other forces on the bear. For part A, at this instant, can you say what the velocity of the bear is? If so, what are the magnitude and direction of the velocity? And for part B, we have, at this instant, can you say what the acceleration of the bear is? If so, what are the magnitude and direction of the acceleration? So to start this problem out, we kind of want to analyze what we're dealing with here. So we have, we'll call this dot the bear, and the boy is pulling it to the right. So we'll call it force boy, and he has a force of 15 newtons. And then we have the girl pulling it to the left. So let's say F of G, and she has a 17 newtons. And so if we're looking at net force, that will be 17 minus 15, which will equal 2. So our net force will be slightly this way, of 2 newtons. All right, so if we look at part A, at this instant, can you say what the velocity of the bear is? We have no information on velocity. We don't know how fast the bear is moving. So for part A, it's going to be no. And then for part B, it says at this instant, can you say what the acceleration of the bear is? And we can, because we know that force equals mass times acceleration. And if you rewrite that equation, you can isolate A to get force over mass, or force really being net force. So we know that acceleration will equal our net force, which we found earlier, for 2 newtons, and then over our mass of the bear, which is said to be 200 grams, but we want that in kilograms, so we'll turn 200 grams, just move the decimal, boom, boom, oh, wrong way, boom, 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 and we'll get 0.2 kilograms. And if you do that equation, our acceleration will equal 10 meters over second squared. So now we've found our acceleration. Now the next problem is, if so, what are the magnitude and direction of the acceleration? Well, we know that our acceleration is going to point in the same direction as our net force. And since our net force is pointing to the left, then we know that the direction of the acceleration is to the left. And that is the problem.